Hi, welcome to the June 3rd meeting of the Kubernetes VMware User Group. Today's meeting is going to cover the ClusterAPI for vSphere. With that said, I've got a presentation ready as an intro. The agenda will be that I'm just going to do 3 quick slides as an intro to ClusterAPI for those who might not even know what it is. And then we're going to switch into kind of a ask me anything / deep dive with my co-chair Miles Gray interviewing Yassine Tijani, who's a key contributor to the ClusterAPI for vSphere. So with that said, let me share my screen and give an intro deck. Can somebody confirm that you can see that?
Yep, I can
Got
see
it.
Yep.
Okay. So what is the ClusterAPI? Well, this is something that started a few years ago, and the goal was to provide a declarative API for simplifying the provisioning, upgrading, and operating of multiple Kubernetes clusters. Now, you can use it to deploy one, but the real value is that if you're in a position of deploying Kubernetes clusters in numbers or frequently for whatever purpose, automation is always going to be a big win for your productivity and potentially even elimination of mistakes. When I say it's a declarative API, well, this is just using kind of the Kubernetes control plane concept itself of stating a desired goal, and you tell it what you want, and as a system, the ClusterAPI is designed to make things happen. This is an open source project, so I'll get to resources in a moment, but it's up there on GitHub. And there is currently broad target platform support. So today we're here to talk about deploying Kubernetes clusters to vSphere, but there are providers for all of the clouds listed here. I have a feeling there might be a few more that I didn't get on the list, and there's probably quite a few more that are underway and maybe not officially published yet, but this is a project that strikes me as having been something that gains momentum, and it's particularly valuable to people in a position that are trying to deploy Kubernetes to multiple clouds and multiple platforms. Maybe the multiple platforms as multiple instances of vSphere, but I know there are a lot of organizations that are using multiple public cloud providers along with on-prem on vSphere. And if you get yourself in a situation where that's something that you need to do for whatever reason, this ClusterAPI can abstract out some of these differences related to the deployment. It would also be a perfect solution if you're implementing your own Kubernetes distribution or installer, because you can offload some of the heavy lifting work onto something that's already been done before and is out there open source. So resources to learn more, there's of course the GitHub repo, and like I said, it's open source, Apache 2 license. The documentation is in a book form, and here is the book link. A couple of our members have written blog posts on it. Miles, who's here right now today. Chip couldn't make it today, but that blog post is very good, and I recommend it. There are also posts out there by cloud providers. The list is really too big to list, but I threw one out there from VMware and one from Azure just to prove that there's activity going on from a number of cloud providers. Then there are a few good recorded presentations. That first one on YouTube is an introduction. The second one, a deeper dive. Finally, the ClusterAPI for vSphere. So the ClusterAPI itself is a spec for implementing ClusterAPI for a particular target infrastructure platform, but each infrastructure platform that chooses to implement one is going to have their own version. So The cluster API provider for vSphere is, of course, the one for vSphere. It has its own GitHub repo link there. And then there's underneath that, I have a link to the getting started documentation. There are a couple YouTube videos specifically on the cluster API for our vSphere. The first one is a demo by Bosky that was done, I think, a year or so ago. So maybe it's dated and doesn't have some of the later features, but I thought it was pretty good. And then a slightly newer walkthrough by a third party just below it. The cluster API for vSphere is running bi-weekly meetings on Zoom, and the link is here. And previous meetings are recorded in the notes at the link you see here. So at this point, I am going to turn this over to Yassine, who's he's been active in the Kubernetes project, I know, since I think 2016, if I'm not mistaken, maybe 2017, but a long time. And Yassine is knowledgeable and active in a number of SIGs. He's also a key contributor to the cluster API for vSphere. With that said, I am going to stop my share and then we'll turn it over. We're going to do this in an interview form, so I'm going to turn it over to Miles and Yassine.
All right, thanks, Steve. I guess, Yassine, do you have any opening things that you want to say about yourself or what you're involved in or anything like that? Just a quick intro.
Yeah, sure. So it's pretty much what Steve shared. I've been with the project since 2016 as a contributor and a user in 1.0. I've worked in several SIGs such as scalability, cloud providers, and more recently I moved into the cluster lifecycle space, initially with kubeadm and then transition into cluster API and specifically Catfee, which is the provider for vSphere.
Cool. So I guess for those of us that are new to Catfee or whatever, what is the goal of Cluster API for vSphere?
Yeah. So in general, the goal for Cluster API is to offer the power of Kubernetes in terms of managing and control loops for infrastructure. This means that you can leverage the Kubernetes APIs to actually manage a set of clusters. And by manage, I mean the whole lifecycle management, be it upgrading your control plane, upgrading the workers, remediation when a machine fails, you want it to be replaced, be it like a worker or a control plane. So this whole lifecycle management aspect of thing is really what drives Cluster API, because when you think about it, you have to, like, if you're not using something like Cluster API, you have to put in a lot of automation around it. You can check projects like Qbip or other projects that use config management. You have to put on a lot of efforts in there to apply the same thing. And Cluster API is just embedding this logic into multiple control loops.
Right. And I wrote a blog post series a while back, and it was just before the one that Steve linked, which was around setting up Kubernetes and VCP and CNS on vSphere before Catfee came along, or Catfee came along, and the amount of stuff that it automates, even just like the kubeadm portions, not having to set up the OSs, all that kind of stuff is really, really useful, because it's not fun to have to do that manually or script it yourself, you know, and then it changes with version to version. So at least there's an abstraction layer between you and that. So there's been, like, the first time I looked at Catfee was just around 0.1.0. I think it was definitely V1 Alpha 1. Whenever we were just getting this thing out the gate. And the last time I looked at it was maybe 0.3.0, which is, I think, when we just introduced CNS support into it. And CNS, for those of you that aren't familiar, is vSphere CSI driver. So prior to that, it was based on the vSphere cloud provider, which is the Kubernetes built-in cloud provider. That was deprecated, and we integrated CNS and CSI. What sort of changed over the last, what was it, maybe a year and a half since then, Yassine? Is there because I know we're at 0.7.8 or something now. So there's been quite a lot of iterations since then. So what are the main things that have changed?
Yeah, so initially, like Cluster API evolved over time, and with it, the providers, and specifically the vSphere provider. So we went from a state where we didn't initially have like management for the control plane. So we did have an abstraction for machines and for how you would do kubeADM stuff, but we didn't have the, you know, this whole orchestration of a control plane rolling out machine one by one. So that was introduced in V1 Alpha 3. We also on the vSphere specific features introduced things such as storage policy support. Initially, we were just supporting data stores. So we started adding a lot of features that are vSphere specific, and we're lately working or introduced a multi vCenter support, meaning that you have like your instance of CapV running on a management cluster. So a management cluster is a cluster that manages itself plus workload clusters. So it's basically your central point of management of Kubernetes clusters. So when you have like your management cluster sitting on one vCenter, you might want to provision clusters in another location within another vCenter. That is a pretty common use case for telcos and retail, where they want to provision against remote sites. So introduced and enhanced support for this by enabling a proper multi-tenancy and selecting the right credentials for the right location. So there's been definitely some enhancements like this, and we're also kicking in for introducing a full multi-AZ support. So it's not really just for, you know, surfacing the zone and region label for the Kubernetes node, but it's also at the VM level, spreading the VMs and the machines properly for you without you having to care about them. So that's something that we're working on, and probably is going to land in 0.7.9.
Very cool.
Which is the upcoming release.
So can I ask a question? Just let me make sure I get this straight. I think I understand it, but I want to make it clear because we might have some people new to this here. This concept of the management cluster, you know, Kubernetes has worker nodes plus a control plane, but this is a concept where you're bootstrapping a Kubernetes cluster so that you can inject the cluster API control plane into it and use it to provision other full independent Kubernetes clusters, right?
Yeah, so the end state of what you want when you are in an enterprise grade deployment is you want a centralized point where you can manage a set of Kubernetes clusters. So this means that you need, and if you're like using ClusterAPI, you need some sort of Kubernetes control plane where you're going to apply a set of CRDs that represent your clusters to manage. So that's what we call the management cluster. And in order to create this management cluster, there's some sort, as you said, like of chicken and egg problem where we need to bootstrap it. So ClusterAPI currently relies on the Kind project. So the Kind project is basically Kubernetes in Docker. So basically the nodes of your Kubernetes cluster are just Docker containers. So we use that to install initially ClusterAPI there so that we're able to provision a first cluster. And when that first cluster that is going to exist in vCenter is fully bootstrapped, we're going to then take the ClusterAPI component and the CRDs that represented this cluster that we just provisioned and move them to that cluster. So that's why we're saying that the management cluster is self-managing.
So that's pretty cool. So what I get out of that then is that you could even start out with a desktop capable of running Docker, you know, just like my own laptop, get the bootstrap running as a Kind deployment of Kubernetes, which is usually pretty quick. But if I want this to be a long running thing, I probably don't want it on my own desktop. So that's a temporary scenario that gets things going. It then migrates over to the vSphere where maybe you get a little bit better high availability scenario. And then
Yeah.
for your long running life cycle over the course of years, even though I started up on my personal laptop, it ultimately ends up being a high availability resource on vSphere. Did I get that about right?
Yeah, and it's especially interesting because at some point you likely want to collaborate on your Kubernetes, your basically your platform management. So you're likely going to have multiple Kubernetes operators and admin that provision clusters. And if you like, if you stayed on your kind cluster, that wouldn't be basically possible. So that's why it's also super interesting to move, once you provision that cluster, to move the resources to a Kubernetes cluster, then you can distribute access to whoever needs to.
So follow-up question. So initially I start this on my own laptop, move it to vSphere. But at that point, is this ClusterAPI, call it a Bastion API, is it capable of deploying Kubernetes clusters both to vSphere and to say AWS, or would I need a separate ClusterAPI if I want to do both AWS and vSphere?
So technically, we usually recommend having a management cluster per provider, but I know that there are some people that are trying to go the multi-cloud way, where they install multiple providers within the same management cluster. So that's really up to who's architecting the platform at the end of the day.
Okay, thanks. I'll turn it back over to Miles. Sorry to be kind of long-winded on my question here.
All good, Steve. So some of the CRDs that are involved in ClusterAPI, like you have machine sets and stuff like that, and that controls the number of replicas of worker nodes and what have you in your cluster. And given, it's sort of like a stateful set or, replica set in that kind of manner where you set a desired number of replicas. I don't know if this is something that's been added already, or if it's something that's, on the roadmap for 1.0 for, either Catfee or Catfee itself. But is cluster auto scaling, horizontal and vertical cluster auto scaling, is that something that falls under the scope of Catfee and Catfee?
Yeah. So like before answering that, I want to distinguish like between what's the role of Catfee and what's the role of Catfee. So usually like we have a set of, generic operations that are likely the same, whether you're on vSphere, on AWS, on Azure, or whatever platform. Things like, I want to upgrade my Kubernetes control plane. There's definitely some generic logic where you have to, roll out your machines. And there's definitely another part that is infrastructure specific, which is how do I create my EC2 instance? How do I clone my VM? How do I provision my virtual machine in Azure? So that's the separation of concern. There's definitely like ClusterAPI in one side that sets, a set of APIs and the contract for the providers to implement, but it also has some generic logic that you can leverage. So it's not only a spec, it is a spec, but also a set of generic APIs and operations. Things like, okay, I want to upgrade my control plane. ClusterAPI is going to do the orchestration, and Catfee is going to do all of the logic of cloning the VM. Things like, I want to delete a machine. Catfee is going to ensure that you're not losing quorum, and Catfee is going to do the actual deletion and garbage collecting of the VM. So now that we stated like both what both projects are doing, you were asking specifically about like
cluster auto scaling. So based on load in a cluster, can I automatically scale out either horizontally or vertically, or a combination of both?
Yeah, so for autoscaler, we actually added support in V1 Alpha 3, so which is Catfee 0.03, and the corresponding Catfee version, which is the 0.7x series. So we added support for ClusterAPI. So basically when you install Cluster API, you can and the cluster autoscaler, you can tell it to use as a provider Cluster API, and based on that, it's gonna do the autoscaling for your machine deployment, which is the concept analogous to a deployment for pods, but for machines. It's gonna basically scale your machine deployment to add the requested number of machines. So we definitely have support for that. I know that we're currently working on vertical autoscaling also.
Could you give me clarification? What exactly do you mean by horizontal versus vertical? What are those two axes? Is it VM counts, host counts, or what?
So when I say, so there's definitely two types here that are relevant. The horizontal autoscaling is when you want to increase the number of replicas of your worker. So you're basically you're having a spike, and I know like in traffic, and you need more machines because your machines are basically have like the maximum pods that they could host. So that so basically you need another worker. So that's where the horizontal autoscaling is interesting. It's gonna basically the cluster autoscaler is gonna basically look through cluster API, and it's gonna set the right number of replicas for use so that it adds the workers. For the vertical autoscaler, what we're saying here is, okay, I have a machine that has like 4 CPUs, but I want to scale and change the number of CPUs for my machine.
Okay, so it makes the worker nodes bigger and more powerful, as opposed to the other direction, gives you more worker nodes. Got
exactly.
it. So you can dynamically change the mix of your worker nodes based on load. Is that what you were getting at, Miles?
Yeah.
Where, okay.
Yeah, I was thinking, if you're tracking a metric, say API response time is usually a good one to go off of in Prometheus or whatever, like you would scale the workload itself with horizontal pod autoscaler. Could you do that for the cluster? Say the cluster gets saturated and it can't scale anymore, if you could scale it out in that fashion too.
Yeah, we're still also working on what sorts of metrics that you can based on. But for now, I think there's just a limited number that are documented on the cluster autoscaler repo.
Cool.
So yeah, we're looking at increasing the metrics, and also adding coverage for the vertical autoscaling, which is basically resizing your machines.
So on the vSphere platform, there's a potential opportunity as you deploy, I guess, horizontally more worker nodes, to be mindful of availability zones so that maybe they're not all on common ESXi hosts. Is that something that takes place? And if it takes place, is it all automatic, or do you have to do something to make it happen?
So as of today, that's what we're actually working on. So it's not only for ESXi hosts, but we're looking at implementing, and the design merged, if I recall correctly. Yeah, it merged, and we have a WIP PR for it, where we basically enable automatically through an API, you represent a set of failure domains, and you can say, okay, these are my failure domains. Failure domain is US West 1. This is my, this failure domain is a compute cluster. The second one is another compute cluster. The third one is another compute cluster. And then Catfee would automatically go ahead and spread your machines through those compute clusters. And as you know, there isn't a native API for what a failure domain is. So we're basically going to allow users to define what a failure domain is exactly for them, whether be it a host group or a compute cluster or a virtual data center. So this is pretty much the model for the cloud provider, the CPI, which is the cloud provider for vSphere.
Yeah, that seems like a huge win, because if you were trying to do that kind of stuff manually, I don't think you did.
Yeah.
Sooner or later, you're gonna mess it up.
Yeah, that's like one of the most requested features that we've had for a while, and we needed to nail the design properly. Now I feel like that we're in a pretty good spot. So like the PR is already up on the repo if people are interested, and we'll likely land it on the next Catfee release.
Would
Awesome.
would the auto scaling also take into account kind of maximums within the compute resources that are available within, say, whatever you define as an availability zone? So say, you know, you'd want to set a limit that I want my underlying ESX host to never be more than, say, max 90% RAM, you know, in order to keep it safe. In one of the two implementations that VMware now has in TKGS, you of course have this concept of namespaces that you can bind up with resource controls, and that seems like a really logical thing to hook into to set limits on the auto scaling. Right now, the only limits available in TKG that I'm aware of are all bound up in just persistent volumes, but not in the ability, you know, the safeguards around the deploying nodes yet.
I guess you
Yeah,
could. Sorry, Yassine.
Sorry, Matt. Oh no, you go ahead.
I guess, Robert, what you could do there is, because I mean, namespaces, frankly, are a resource pool coupled with a VApp together, right? That's what makes up a namespace. And CapV rather requires a resource pool to deploy the machines into. So you would have to create a resource pool. Obviously, you could use the root one, but you wouldn't do that anyway. But you would create a resource pool and put a limit on the resource pool. Then that would, you know, certainly ensure you don't go over that. Whether, you know, how constrained that resource or the shares are in that resource pool would affect CapV, that would be for Yassine to say.
Yeah, for the resource pool, I guess that would CapV itself wouldn't be affected, but it would certainly affect and limit what you're basically what you're trying to deploy. So if you're basically splitting your deployment model, where you can say, okay, I'm allocating this resource pool for these users or set of clusters, then you can basically feed CapV a resource pool per cluster, and then you can group your clusters per resource pool, so that even if you have things like SLAs, where you basically, or like quotas for each team, for example, you can say, okay, for this team, I'm dedicating this resource pool, and whenever they provide or wherever you create a cluster for them, you can use that.
How about other constraints? Like suppose I'm trying to compose a Kubernetes worker farm for machine learning training, and I want them to go to hosts that have GPUs. Are there ways to give CapV clues that's your desired goal so that it makes that happen?
So GPUs are kind of like today not automated through CapV, because we're still looking at the design on how it is gonna go. We definitely started some of the work there by enabling some of the image builder. So image builder is the project that we use to build the OVAs that we're gonna use for cloning the machines. So yeah, we started doing some changes for in the image builder space to enable proper support for things like PCI pass-through or whatever, like yeah, I think it was.
Yeah, I was thinking along the lines of it having an affinity for particular hosts or an anti-affinity.
So yeah, that's the part that isn't yet automated, because basically you'd need things like host groups, VM groups, and affinitize your the hosts and the VMs. That's the only bit that isn't automated yet. Plus, we need probably to add some logic to add device plugins and things like that if you want to.
Yeah.
You want to consume.
I'd like to suggest maybe even hard coding in this specifically for GPUs isn't the way to go, because on the Kubernetes project, I'm also active in the IoT Edge working group. And there's scenarios where you've got dedicated hardware out at edge for data collection devices and things, to where potentially the same sort of thing goes on, but it isn't GPUs per se. But if you could somehow label the hosts and put directives in your declarations for Catfee and Kubernetes deployment, that might work out as a really generic solution that would hit the nail on the head for a lot of use cases.
Yeah, we're actually like the current design is, or at least the current plan for the team and the community is basically provide at some point an abstraction or a way to say that you want some sort of affinity between a VM and a group of hosts without it being specific to a feature, things like GPU, SRIOV, or any other device specific feature that is going to just be available on a subset of hosts. So there's definitely like an API that is being discussed to actually like have it a generic, like have it in a generic way, as you were discussing.
Yeah, I guess part of the problem is that vAPI doesn't do service discovery very well, especially for GPUs and stuff like that. And as far as I'm aware, like vCenter doesn't advertise, you can't query, which ones have this type of PCI device. You would have to iterate over every host currently, find out what PCI devices are and do your own filtering and stuff. So it's not, I think there's some work that needs done on the ESXi and vCenter side as well to support anything that we would do in Catfee around that.
Yeah, at least like the current way is we'd need to iterate over the collection of hosts to actually filter things out.
Which can be very, very heavyweight given the size of some estates as well.
But
yeah.
Also
Sorry, go ahead.
Yeah, no, but with vSphere 7, if I'm not mistaken, this should be possible though with assignable hardware if you configure that in the template. Because then when it gets placed in vSphere, it would just be placed on a host that would adhere to the assignable hardware feature.
Yes, you're correct. DRS has enhanced support for things like GPUs. So since the Catfee project is like a community project, we're also like trying to, as much as possible, support 6.5, even though that we're not making commitments to it. We're trying to not break it deliberately, but we're also and mostly supporting also like 6.7 U3 plus users. So we're definitely going on the path of having a bimodal approach where we basically have we make Catfee aware on which version and make it query on which version of vSphere it's running. And based on the version, we're going to either take a path where we're going to use the existing 6.7 U3 APIs or use the 7+ new APIs. This is also applying for things like VM service that was announced recently. We're planning like, and it's today open sourced. So VM service is probably going to make it at some point into Catfee.
Cool, that makes sense. I was having a look at Catfee the last couple of days, as I'm sure you're aware, Yassine, because I've been bugging you on Slack. And I noticed there's a migration underway at the minute away from HA proxy, which is deprecated. And I should preface this whole thing with Catfee lets you deploy highly available control plane clusters. So you need a load balancer in front of it. So up until, I'm not sure how recently, but not too far in the distant past, the answer was HA proxy, and it would deploy HA proxy load balancer in front of it for you, assign an IP, and then that would load balance your control plane. And we're moving away from HA proxy to Qbip. Could you talk a little bit about that move or why it's necessary, what the advantages are?
Yeah, so the history here is that when we moved from V1 Alpha 2 to V1 Alpha 3, we like one of the biggest items for revving the API version of ClusterAPI was to introduce KubeADM control plane, which is a CRD that enables lifecycle management of the control plane. So instead of before you had to go ahead into each single machine, change the Kubernetes version of the of its KubeADM config, and do it from a machine to another. What we did instead is introduce that CRD to introduce this rollout logic. And as part of the contract of this rollout logic, we needed to have a stable control plane endpoint. Before, the control plane endpoint was just one of the machines that was created as part of the control plane. So we introduced HA proxy, but over the time, it proved pretty challenging to manage because we had to build an OVA, we had to deploy it, and we had also to manage the HA proxy configuration. And there were also multiple challenges. You couldn't feed it, for example, like a DNS record. It was a single replica. If the VM had an issue, you didn't have basically failover. So for those reasons, we started looking over in this space, and we partnered with the Qbip community to actually bring HA to Catfee. So Qbip is like a pod-based like failover / load balancing solution, where basically you're creating, you're basically adding Qbip as a static pod on your control plane machine. And by adding, like, it's not like something manual, you just do it through the KubeADM control plane API, because you can basically drop files through this API. So you can add the static pod there, and that's what we do in our default template, basically. So yeah, we add those static pods, and one of them is going to be basically elected as a leader and is going to pin a VIP for your control plane, your first control plane machine that gets basically that wins the leader election. And you can optionally even enable load balancing across the other control plane nodes. So Qbip has two modes. The L2 mode, which is the default mode we ship with. So your machines needs to be within the same network. And it also has a BGP mode where if you wanted to have machines into different networks, then that would enable you to do so. So that was the rationale behind moving from HA proxy to Qbip.
So when ClusterAPI for vSphere deploys Qbip, is this provisioned strictly for purposes of a high availability control plane, or could a user organization also use it as a load balancer for their own workloads?
So currently it is strictly limited to, so at least in our default templates. So by template, so when I say templates are basically just a blob of YAML. So it's a manifest that is a blueprint on how to create a ClusterAPI based cluster. And usually you just our CLI just templates this YAML with the values such as the resource pool, the data store, the network name, and things like that are specific to your context, and create the cluster. So we ship a template for users to use and modify, and in it we're just including Qbip as a control plane endpoint solution. But we are aware of community users that are also using it to load balance and implement service type load balancer.
Yeah, it's got some other really nice features as well. If any of you run home labs, like it's got an ability to take a DHCP lease. So I don't know if any of you are familiar with Metal LB, Metal Load Balancer. It was a project came out of Google and was, I think at the minute is abandoned. Maybe it's got some new contributors, but it's not in a great state. And that was very popular for home labs because it was simple. You would give it a range of IPs that it could allocate service type load balancer from, and away you go. So it's really good for Raspberry Pi clusters, that kind of stuff. Qbip goes a step further and lets you just pull leases from DHCP and then reverse ARPs for those DHCP leases that it's gathered. So you don't even have to put a config in. So it makes it super simple to roll that out on any network without having any prior knowledge of static networking, any of that kind of stuff.
Yeah, that's exactly where I was wanting to go, Miles. Nice to hear.
There you go. I think he also added Dan Finneran, who works over at Packet Cloud, I believe. And Yassine's been working on Qbip as well, I think, as a contributor. They added support for UPnP as well. So again, another perfect home lab use case where maybe you've got your DHCP network and you want to advertise a service externally. You don't want to mess with your firewall. You can let it advertise through UPnP and open that port up for you as well. Obviously not a security best practice, but look, if it's home lab, it makes it work, and it's a really convenient way of doing things.
Yeah, and like for your control plane endpoint, we also support things like, okay, you feed Qbip a DNS name, Qbip is going to resolve and then broadcast it so that it's basically a VIP for you. So it enables you to fully use DNS if you wanted to, and it also supports things like DDNS and dynamic DHCP by just grabbing a lease and still renewing it, but you're still interacting with a DNS record.
Really this sounds like a potential subject for a future user group meeting, because I think 2 years ago we covered load balancers, but a lot has changed since then. So maybe we'll postpone going into a deep dive on Qbip, except as it relates to Catfee. And we'll keep it in reserve. Not that it isn't an interesting subject, it is, but we can get another monthly meeting out of this, maybe.
Sure. We can get Dan and maybe Yassine to come on and talk about it as well.
Yeah.
So I got one more question for you, Yassine, and then there's a question from Tim in chat there as well that I'd like to get to. So currently we're on 078, 079 is probably close on the horizon. What does stable API for Catfee look like? Is there like a well-defined road to stable, or are we kind of just giving it lots of soak time, and whenever we feel like there's nothing to add, we'll declare it stable?
So that's a great question. So like ClusterAPI itself, like if you see the API and the API version, you're gonna see it that it's on V1 Alpha 3 and soon V1 Alpha 4. So while the APIs themselves are marked as alpha, the project itself is a GA grade project. This means that we provide conversion webhooks between API version. We have a strict deprecation policy. We're not breaking users. So we are actively reliant on it. People are building products and projects around it. So we definitely do not consider this as an alpha grade project. So we have a roadmap for going to beta and eventually GA. But yeah, like just keep in mind that while the APIs are alpha, the project maturity itself is far more than that, because we are considering like in-place upgrades, rollouts, and not breaking users. So for the roadmap, we definitely have some items that we need to have in ClusterAPI before moving to beta. The first one that comes to my mind is the load balancer API. So currently, if you want to provision load balancers, it's up to the infrastructure provider, so vSphere, AWS, Azure, to provision one for you, and you don't have like any API to interact with if you want to integrate or do some automation around the lifecycle of the load balancer or provision it or provide an API to the user to fine tune the configuration of your load balancer. So we're actually working on a proposal upstream in ClusterAPI to define what this API would look like. So that's the first item. The second item that we're working on and that is shipping on V1 Alpha 4, which is right around the corner, I believe, shipping around mid-June probably. Yeah, one of the item is security. So we're bringing secure node attestation for ClusterAPI. KubeADM by default auto approves any certificate signing request for a given node. We're actually implementing a mechanism where we actually verify the identity of the node that is submitting a CSR either through TPM or any way that a provider deems accurate to verify the attestation. So we're actually bringing that aspect of, ensuring that this node is the right node that is doing a CSR to basically join the cluster. So this is an item that we're targeting for this cycle, and the load balancer API is something that we're targeting for the V1 Alpha 5 cycle. We also have a discussion / a roadmap in the ClusterAPI repo. So it's a new feature in GitHub that is called discussions. We have one to track the path to GA.
Okay, awesome. Thank you, Yassine. There's a question from Tim in the chat here. Tim, I don't know if you just want to explain this a little bit more. It looks like what you guys are doing is running something other than vSphere or vRealize as your IaaS provider, and you're looking to hook Catfee into that. Is that correct, or do you want to come and unbutcher what I just said?
Yeah, that's basically it. We have a number of operations that have to happen simultaneously for compliance and operational, readiness and that sort of thing outside of just cloning VMs. So there's a system internally built that handles things like DNS creation, DHCP, IP reservations, CMDB record management, and so forth. So I'm the provider author for the Kubernetes solution that interacts with that system. I'm just wondering how I'd get started with Catfee, if that's an option to use custom providers.
Yeah.
Specifically around the question of auto scaling, that's something we haven't solved right now. We have alerts and things, and operators handle scale up, scale down, and I'd love to get rid of that.
Yeah, so I'll start with the first part. Catfee today works as long as it has access to the vCenter APIs, the vModel APIs. So we're doing work through GoVMommy. So as long as those APIs are available, you as the administrator of the platform can leverage Catfee to do your multi-cluster lifecycle management. So yeah, as long as as Catfee has access to those APIs, you should be fine.
Thank you.
So I gather, Tim, what you're looking for is kind of an opportunity to watch deployments of VMs, so you could, maybe do operations on external infrastructure that is beyond vSphere as things are getting deployed. Is that the purpose of going through this homegrown IaaS provider?
Yeah, partly it's that. Partly it's also just a separation of duties between teams. So I'm not part of the virtualization team. I partner with them. Their preferred VM management solution is a homegrown tool that's written by yet another team. So it's kind of the bridge between our teams. We do have admin access to the vSphere APIs. I'm using PyVMommy today. And so the same sort of service account could be leveraged. But yeah, it's that mimicking the organizational hierarchy as well as dealing with some internal requirements.
Yassine, it kind of strikes me, and maybe this is already there, that one issue with provisioning of these VMs related to infrastructure is a lot like provisioning of pods, where you've got something like admission controllers, where you can keep an eye on pods being provisioned, maybe fill in the blanks or validate or audit what has been declared related to these, even patch things up. Is there a way to do this? Because it looks like when you provision pods, it's going to pull container images out of a registry, patch up config, and maybe have opportunities to write custom code that reacts to these things as they're provisioning, and maybe even manipulate settings. Doing that would be really cool as you are pulling out these OVAs to provision Kubernetes nodes. You know, there was a question on the Kubernetes Slack just in the last day of somebody who wanted to enable nested virtualization in deployed Kubernetes worker nodes, because I don't know if they were doing KubeVirt or they were doing something that was building container images, but in any event, they wanted nested virtualizations enabled. Is there things in place to do this with Catfee?
So if you want to hook in your own control and validation and default in there, that's definitely possible. We as part of deploying Catfee, we provide an infrastructure component.yaml, which is what our CLI is installing. So it can read that from either from GitHub or your local file system when you're bootstrapping the management cluster. So technically you can pull out that infrastructure component, hook in your own webhooks. We already have like validation and like defaulting and validation webhooks. So you can get inspired of those in terms of what CRDs you need to create, and you can hook in your own pod that does validation against vSphere machines to see what is allowed or not.
I'm just wondering what the best practice is. Like, suppose in that use case where I want to enable nested virtualization, I can see two ways where you'd publish a special OVA that already has that setting engaged. But the alternate would be that you have a more generic OVA, and as this OVA is getting deployed, something jumps in and manipulates the VM setting. So it wasn't originally that way in the OVA, yet the end result ends up with that engaged. Do you have the option with Catfee of doing this either way, or is there one way to accomplish that that's recommended?
So in Catfee, we also added recently an option to tweak the VMX keys. So if you have like things that can be done through that, you can definitely do it. Otherwise, you would likely need to like if there are definitely like if there are settings other than the VMX keys that you'd want to tweak, you can definitely watch the ClusterAPI machines and react, as you said, like react once they're created to do your own automation.
I see Robert asked a question in chat. Robert, do you want to jump in here and put that on the stage?
Yeah, this is just to go back to Tim's question. I was just thinking about it. I was afraid maybe it was being overthought, but isn't I'm not that familiar with Kubernetes yet generally, but isn't Catfee simply controllable through the Kubernetes API?
You mean the provisioning of clusters is controllable through? Yeah, it is, correct.
Yeah. Okay. So so I was wondering if Tim, maybe that's all you meant, as in, if this is, you know, how do you provision Kubernetes stuff through ClusterAPI where you talk to the K8s API?
I think what Tim was, well, Tim, you can speak for yourself.
Yeah, I guess that would, we don't have a way today to do node provisioning through the Kubernetes API. I know that there are projects like Metal Cubed and so forth for bare metal that allow for that. I don't know of something like that that would work with our infrastructure provisioning system, but there could be something I'm just missing.
Yeah, I'm not sure. I think my interpretation was more given their infrastructure pipeline that they had, is whenever a cluster gets rolled out, they maybe wanted something to watch the events in Kubernetes for a particular, say, machine type or whatever, or like Yassine was saying, write their own validation or defaulting webhooks, redirect them somewhere else, like via their provider, and then have them hook back in again, or something similar to add the extra compliance bits and pieces they needed on top of just provisioning the nodes themselves.
Yeah, that's a pretty good overview of what I'm looking for.
Cool.
Okay, time check. We're down to having just a few minutes left. If anybody wants to jump in with last minute questions, and if we can't make it and we have to cut it early before your question gets answered, Yassine is out there on Kubernetes Slack, so I think people can get a hold of him there, right?
Yeah, I'm mainly hanging out in the cluster-API Slack channel or ClusterAPI provider vSphere. So yeah, feel free to reach out with any like ClusterAPI question, and yeah, we have, I think, like on the deck that you linked, Steve, I think we have, like, you linked to the getting started guide, which should get you through how to get a cluster up and running. It should be like a few CLI commands, like 1 or maybe 3 to get your first cluster up and running.
Yeah. And I've put a link to that deck. I've shared the deck and put a link to it in the agenda note stock for this meeting. So you can get it there. And it also has links to the other things like the Catfee community meeting and other resources. So final call, if anybody wants to jump in here with questions. And the other thing, if you want to jump in here with ideas you have for what we should discuss in the next meeting a month from now, go for it. Okay, I'll take silence as nothing to add. And with that said, thank you everybody for attending. I felt it was another great meeting, and I look forward to seeing you a month from now in July. I'll have to look at the calendar. I haven't actually done that, but at least in the US, that is a potential holiday week. But at least for now, we'll assume that that meeting is still on. So bye, everybody. Thanks for attending.
Thank you.
Thanks, y'all.
Thanks again, Yassine.
Sure.